Okay, in this video, we're going to try and understand piecewise functions on a graph. You can see that this is sort of a mess. It's almost like you open up a box of pieces, like for a model or a puzzle, and they're just lying all over the place, right? This is an example of the graph of a piecewise function. Here's the most important thing that you need to see is that if you go to any x value and draw a vertical line, you will see that it does not intersect the graph in more than one place. Okay, so as we go along here, this particular piece stops here, and you can see that a new piece picks up. But notice that this piece has an open circle, and this piece also has an open circle, but that there's a point right here. And that means at this x value right here, this x value is not defined on this piece, and it's not defined on this piece. It's defined at this point right here. As we go along this piece, we have some x values that are defined on this piece, and then we have a closed circle at the end of it. That means that this x value is defined on this piece with the closed circle. But when we go down, there's a new piece that picks up here, but it has an open circle here. That means that this piece is not defined at this x value, or vice versa. This x value is not defined on this piece. And then we move along this piece for all the x values, and then when we get to the end of it, it transitions to a new x or a new piece, okay? So what we can do is we can identify all the transition values on this piecewise function. This piece stops here, so that's a transition value. And then this piece stops here, so that's a transition value. This piece stops here and begins here, so that's a transition value. So we have three transition values. We have -4 is a transition value, -1 is a transition value, and it looks like 1, 2, 3, and 4 is a transition value. And what we're going to try and do here is we're going to try and write up the function, this piecewise function. And so we're going to write f of x is equal to, and then we're going to write, now this piece is going to have 5 pieces. You may see 1, 2, 3, 4 pieces, but this point right here is also a piece, and therefore we have to define that one separately. So we have 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces on this piecewise function. So I want to leave enough room for 5 pieces. Usually the middle one, this will be the third piece right here. This will be the second piece. This will be the first piece. This will be the fourth piece. And this will be the fifth piece. And now what I'll do is around the whole thing is I'll do a big bracer. Okay? And then now I need to identify what the equations are. They're all linear functions. This one's a constant, but this is a linear function. This is a linear function. This is a linear function, and this is just a point. So we're going to define each one of these pieces on this piecewise function. Okay, so this first piece right here, we need to identify the slope of this particular graph. Well, to identify the slope, I'm going to need to identify the rise over the run, and it looks like it intersects this point right here, and it also intersects this point right here. And so it looks like it goes up 2, so plus 2, and it goes over 1, 2, 3, 4, 5, so plus 5, and it looks like the slope of this function is 2 over 5, okay? And then if we were to continue this 2 over 5, from this point we could go up 2 and then over 5, 1, 2, 3, 4, 5, and it looks like it's going to intersect the graph right here at -3, okay? And so that means that this line right here is the graph of 2 over 5x minus 3. Now that we have the graph, we need to now identify its domain. And so because, whoops, hang on, let's go back there. Because, I just got rid of I want to leave that arrow on there. All right. There we go. And because it goes to -infinity here, we know, or it has an arrow here, it goes on to negative infinity. So we know that it starts at negative infinity and it goes up to this transition value negative 4. So that means that this is going to be for all values of x that are less than negative 4. Are we going to include negative 4? Well, look at this. This is an open circle, so we are not going to say or equal to negative 4, okay? What about at negative 4? Well, at negative 4, we can see that the graph is defined at this point up here, which is 5. This is 1, 2, 3, 4, 5. And so this graph is defined at negative 4 for a value of 5. So we know that this graph is defined for 5 when x is equal to negative 4. Okay? The next piece is this piece right here, and this is a constant. This is the graph of y equals 2. And so we're going to say that the graph f of x is equal to 2 when x is greater than negative 4 but less than negative 1. You can see right here that this piece goes between negative 4 and negative 1. Okay? And because of this this closed circle here, it's going to include negative 1. So this is going to be when x is greater than negative 4, but less than or equal to negative 1. Once we get to negative 1, we are on to this graph. Now this graph right here looks like it has a slope. Let's see, a slope of, it goes up to this point right here. So it's going up 4 and over 3. So up 4 over 3, and therefore it has a slope. It's a 4. It has a slope of 4 over 3, and it has a y-intercept of negative 1. So this is going to be 4/3 x minus 1, and it goes from negative 1 up to 4, but it has an open circle at the end, so it does not include 4. So it's going to go from negative 1 x up to 4, okay? And then the last piece is this piece right here, and I'm going to clean up a bunch of this stuff. I'm going to erase a bunch of this stuff so that I can see this other graph here. There we go. And you'll see that it has a negative slope here, okay? Let's say it goes from here and it goes to here. That's a negative 2, and over 2. So it has or that's plus 2. So it has a slope of negative 2 over 2, which is negative 1, okay? And so if we follow this backwards, if we follow this graph backwards with a slope of negative 1, we'll see that it intersects right here, which is positive 6, okay? And so this is the graph of negative x plus 6, because it has a slope of negative 1, and it has a y-intercept of plus 6. So this is the graph of negative x plus 6, and it goes up to infinity. It goes up to infinity, but it starts at right here at 4. It starts at 4, but it has a closed circle, and therefore it's going to include 4. So it's going to go 4. Well, hang on, 4. That doesn't look pretty. There we go. Which is less than or equal to x. So x is greater than or equal to 4, but oh, I don't have to put the infinity in this format. I can just say, let me rewrite this. This is actually kind of ugly. This is for all values of x that are greater than or equal to 4. So I'm just going to say x greater than or equal to 4. Okay? And so this is how we can take the graph of a piecewise function and we can translate it from a graph into a function. And you could do the same thing where you take the function and translate it into a graph. In the next video, I'm going to do one more example of this.